we bought a field. After 50 years of living in towns, we wanted to rebalance our ecological footprint and try to pay back our 2,000-ton carbon dioxide debt. It took more than 5 years to find a suitable site. In desperation, we even considered derelict chapels, pig farms, and ex-utility sites. Local authorities could do much more to harness the energy and resources of the many people like us looking to live more lightly. Even before we'd exchanged contracts, we began to develop proposals. Our first idea was an earth-sheltered hole in the ground, which then transformed into a mound above the ground to keep it light and dry. It then morphed into a curved glass teardrop to make it even brighter and lighter. Then we wrapped it around itself like a spiral circus tent. In the end, we settled for a spiral winding round a tower. We quickly realised that eco-design is a trade-off, and we decided that our challenge was to balance sustainability, beauty, and convenience. The curved shapes were the most efficient way to encase the maximum space with the minimum of materials. The south-facing glass conservatory would make it bright and light and provide masses of solar gain in the winter. And the tower would provide thermal mass, a big storage heater, in the middle of the house to help keep us warm in winter and cool in the summer. Let's take a walk around the spiral of the house. We call the conservatory the bananarium, and we've added screens and fans to keep it cool in the summer. This cabinet houses our 8 kilowatt solar PV control system, together with a bank of batteries to store the energy that we make in the day. These are salt water batteries. We export twice as much electricity as we use, and it's only in the middle of winter that we need to take any power from the grid. We have a second-hand Nissan Leaf electric car, which we also charge from our solar system. It has taken 6 years to pay back our initial cash and the embodied energy investment to make the solar cells. They should work now for free for another 15 years. Embodied energy is the energy it takes to make something. While energy efficiency is now considered important in house construction, embodied energy is seldom considered and currently not legislated for. Here are some of the things we did to minimise the energy it took to make our house. Wherever possible, we used local suppliers and contractors. Our walls are made from heritage straw bales, squeezed tightly between timber trusses. The straw was grown on a local farm, and like the mud dug from the foundations, we used human power to mix, move and apply it. In all, we used about 100 tons of cob, which we pressed and formed by hand. We skimmed the cob on the external walls with a lime render to provide a weatherproof shield. Every time you come into a straw house, it feels like it's giving you a hug. It's very quiet and naturally warm in winter and cool in summer. We salvaged the kitchen units and worktops from the broken bungalow. Our neighbours donated wall tiles. The butler sink and the taps were second-hand from eBay. The wood-burning stove is the smallest and most efficient we could get. It is the only source of heating in the house, and in winter we mostly only light it in the evening. We were very lucky to buy a job lot of 8 dipped panel doors on eBay for 99p. The hardboard panels had warped badly in the stripping process and no one wanted them. We carefully removed the panels and Christopher replaced them with translucent artworks inspired by the reeds and dock seed heads around our pond. We left some of the cob walls exposed inside the house. In the kitchen, we pebble dashed the cob with oyster shell chicken feed, which has given a beautifully tactile finish. In the bathroom, we were inspired by Gaudi, and we have used broken donated white tile mosaics. The basin and the toilet were rescued from the bungalow. We combined a vertical and horizontal reed bed to process our black water from the house. The solids are settled out into a tank, sand filters out finer particles of waste, and microbes in the reed's root systems break down pathogens. The treated water runs out to a pond. Being responsible for our own living waste system means we are very careful about what we put down the drain. We allocated a big budget for a solid oak spiral staircase, but like most other self-builders, we ran out of cash and were forced to rein in our ambitions. We're glad that we did, as the compromise, designed in partnership with John our carpenter and a local blacksmith, is both lighter and more beautiful than we could have imagined. We learnt early on that the most important feature of any eco-build is insulation. We worked hard to ensure that we insulated under the floor, over the roof, and around all the walls with at least 300 millimetres of the most effective insulating material. To restrict the embodied energy, we used natural materials like wool, thermofleece, recycled newsprint, warm cell, and cork slabs. As well as insulating deeply, we were extremely careful to draft-proof. We were not sure how airtight our straw and cob walls would be, so we meticulously taped all the joints and junctions. This paid off, as our air permeability test was exceptionally low and met the passive house standard at the time. If you've made a completely airtight house, you really need to consider how you're going to ventilate it. Expelling warm, stale air and drawing clean, cold air in from outside is really inefficient and cancels out all the good work insulating and draft-proofing have achieved. Mechanical ventilation and heat recovery, MVHR, mitigates this by using the heat in stale air to warm the fresh incoming air. We have fresh air inlets in each of the living areas and stale air extractors in the kitchen, utility and bathroom. The MVHR unit also controls humidity in the house, extracting excess condensation from the incoming air. We made our own lime wash for the outside using a mix of lime putty and water. Inside, we chose a commercial cheese paint, which is a lime wash with added caseins, that's milk proteins, to stabilise and minimise dusting. Outside, we've created 3 ponds. We have planted almost a mile of native hedges, hundreds of native trees, and we are currently establishing a forest garden next to the house. Our spiral living roof has a shallow substrate. It supports sedums on the steeper gradients and more extensive grasses and weeds as it levels out. We cultivated the sedums for our green roof on site while we were building. We are very grateful to the many experts and friends who have contributed to making our house such a comfortable, productive and sustainable thing to live with. Thank you.